Got to put on some safety equipment for this one. My boys love to be hands-on for science experiments, but when I bust out the 98% concentrated sulfuric acid, they're going to be watching this from the house. An acid, in general, is a molecule that has an extra proton that it really wants to give away. So what can extra protons do? Well, look at this setup where I mix acid with a cup of table sugar. Almost by magic, it has turned into what I call the Devil's Cheeto. Let me explain how this happens on a molecular scale. Table sugar is basically 2 rings of carbon atoms with a bunch of ho-hos hanging on. The actual term, I think, is hydroxyl group, but I'm a dentist, not a chemist, so cut me some slack here. In comes sulfuric acid, and as I've mentioned before, it really wants to give up its protons. A proton is just a hydrogen atom without an electron, so it looks like this. H plus O is H2O, and I'm pretty sure that's just water. When you mix sulfuric acid with a sugar or a starch, it will break it up to form water with a bunch of carbon left over. That's why the sugar turns black, and the steam coming off is just the superheated water. After ruining a folding chair and several drinking glasses with this reaction, I decided to try my luck with some toilet paper. Because of the rolled layers, I'll have a high surface area for the reaction to take place. Let's see what happens. The roll gets destroyed. Fun fact, pH is a scale of how acidic or basic something is. The lower the number, the more exponentially acidic it gets. Stomach acid is around pH 2.0, but 98% sulfuric acid, like the one I'm using, is an insane pH of negative 1.1. Yes, the numbers can be negative for when something is just stupid acidic. My sulfuric acid is over 1,000 times more acidic than stomach acid. I wanted to try sulfuric acid on honey, so here it goes. It was not as flashy. In fact, this footage is sped up quite a bit, and the reaction still goes slow. The next logical choice for my acidic victim was a pop-tart. I was able to toast it quickly, but eventually chose not to eat this one. Just for fun, I tried pouring sulfuric acid into Diet Coke, thinking nothing would happen. No sugar, no reaction, right? Wrong. I later discovered that sulfuric acid is highly reactive in water. So, lesson learned. It sprayed super acidic carbonated droplets everywhere. Good thing for my protective eyewear and clothing. Now I just have to get a hold of some fluoroantimonic acid. It is an unbelievable 20 quintillion times stronger than this sulfuric acid. To put that in relatable terms, if you stuck your hand in a bucket of the stuff, you would pull back a stump.